video, we're going to expand on the ideas that we talked about last time, which was the basic ideas of the sine and the cosine graph. And we'll start taking those graphs and moving them around through a series of movements that are called translations, both horizontal and vertical, and then combinations of the two. When we have a horizontal translation, we're going to be moving the graph to the left or to the right. And we know that that happens when there's a number that is inside the parentheses where the angle is of the function that we're trying to graph. One of the things that's sort of interesting is that the blue graph that we see here in this picture is our original graph. When we add a number like this, we end up actually moving the graph to the left. And when we subtract a number, we move the graph to the right. That has to do with the fact that when we think about solving something for 0, like if we had x plus 3 inside parentheses and x minus 4, if this whole thing was equal to 0, the two solutions here would be -3 and +4. So when we're inside parentheses, we're actually moving a graph in the opposite direction that we would think. We would think that plus would move to the right, but in this case, it's actually going to move to the left. So again, the numbers are going to move in the opposite direction, we would think. And this movement is called a phase shift in terms of a sine or a cosine graph. So here's an example of sine of x minus pi over 3. You can see that rather than starting at 0, the graph is starting at pi over 3. The whole graph moves over to the right by pi over 3 units. Now, if we were not, if we didn't have a picture to start with, how would we get this picture? Well, we know that the amplitude for this graph is still going to be 1 because there's no number that's changed in the front of sine. So the amplitude is 1. We know that the maximum value will be 1 and the minimum value will be -1. The period is going to be 2 pi. We don't have any number that's multiplied here by the x, so the period hasn't changed. And so when we think about the x and y values, normally the period starts at 0 and would go to 2 pi in this case. And then we can split up all of the sections here. But we're going to move every single one of these x-coordinates to the right, and so we're going to add pi over 3 to all of these values. The first one's easy, right? 0 plus pi over 3 will just be pi over 3. That matches what we're seeing here in the graph, that our starting point is at pi over 3. To get the next value in your calculator, what you can do is, again, as a reminder, don't use the pi symbol. You're going to type into the calculator 1/2 plus 1/3. And when you do that, it'll tell you that you're going to get 5 over 6. And so we'll write this next value as 5 pi over 6. For the next one, we'll do 1 plus 1/3, and we'll get 4/3, and so we'll write the answer as 4 pi over 3. I'm just showing you the calculation that we do to get the 5 points. Pi over 3, 5 pi over 6, 4 pi over 3. The next one's going to be at 11 pi over 6. And then the last one here is going to be at 7 pi over 3. Again, let the calculator do the addition of the fractions for you, and it'll get the common denominators and do all that, the heavy lifting for you. All right, so the only thing that's changing in this graph are the x values. Everything's shifting over to the left. the y values aren't going to change, and we're going to follow the same patterns we've talked about for sine, where we start at the center, go up to the max, center, min, and then center. The center points are all going to be at 0, the max is at 1, and the minimum is -1. So hang on, let me change the color here. 0, 1, 0, -1, 0. So these are the 5 points that we're going to graph, and we can see that they match up with the picture that we have here. Here's a different example that has a phase shift, but also has an amplitude change. Now, we said that when there's a number that's changing the graph, it's going to go in the opposite direction. So since this is a positive number, this graph is going to shift to the left by pi/4. It always goes in the opposite direction when we're inside the parentheses. The amplitude for this graph is 3. Again, that comes from the number that's multiplied in the front. And the period for this graph is also going to be 2 pi because we don't have a number multiplied in front of the x. So let's think about the x and the y values. Again, normally the x value is going to start at 0 and go to the end of the period. So I think about what the values would be if I didn't have any changes. And then, because I'm moving to the left, I'm going to get the actual values for x, I'm going to subtract pi/4 from each of these values. So for the first one, 0 minus pi/4 will be -pi/4. That matches up with where I'm seeing this graph starting, right, at -pi/4. The next one, we'll type into the calculator 1/2 minus 1/4, which is going to be positive 1/4. So pi/4. Then we'll have 1 minus 1/4. That'll be 3/4, right? 3 pi/4, and so on. 5 pi/4 and 7 pi/4. To get the y values, we're going to think about cosine. The pattern that cosine follows is starting at the max, going to the center, min, center, max. The center is going to be at 0. Because we have a change in the amplitude, the maximum is going to be at 3, and the minimum is going to be at -3. So here are the sets of ordered pairs that we would graph, and we can see that they match up with the 5 key points on this graph that we have here. For this next example, we have 3 components that are happening. Actually, it looks like we have a reflection as well. Let's talk about what each of the components mean. Now, first of all, we see that the amplitude is going to be 2. Remember that we take the absolute value of the number that's multiplied in front. The negative sign means that we're going to reflect across the x-axis, right? Okay. Now, when you have a number that's multiplied in front of the x, that changes the period. And it also is going to affect the potential phase shift. So what we need to do before we consider both of these is we actually need to factor that out. We're going to factor that so that the 3 is in the front, and we end up with pi/3. What I'm doing is I'm dividing this by 3, and I'm also dividing this by 3 so that the 3 is coming out into the front, because the way the formula is written, the period is actually going to be outside of the parentheses. So for this, the period is going to be, the normal period is 2 pi, and we divide by that number 3. And then the phase shift is here. This is going to move to the left by pi over 3. Left because it's positive, and it always moves in the opposite direction that we think that it would. Okay, so let's talk about what happens here. Quite a lot of moving parts here. All right, first let's talk about the x values. We normally would start at 0, and we would go to the end of the period, which is 2 pi over 3, right? So I'm going to start at 0, and I'm going to go to 2 pi over 3. The halfway point between those would be pi over 3. The halfway point between those would be pi over 6. And then the middle between these, I'm going to do 1/3 plus 2/3. And then I'll divide that by 2, and that's going to be 1/2. So this is going to be pi over 2 is going to be right in the middle of those two. Okay, those are what the values would be if I didn't have a phase shift. So this is just taking the beginning at 0 and going to the end of the period and splitting it up into equal intervals. Now what I'm going to do is I'm going to subtract pi over 3 from all of these values to shift everything to the left. So in the calculator, I'll have negative pi over 3 as my first value here. And then I'll do 1/6 minus 1/3. 1 over 6. Again, I'm leaving the pi symbol out. 1 over 6 minus 1 over 3. And I'm getting negative 1/6. Negative pi over 6. Then I'll do 1/3 minus 1/3. Oh, that's going to be 0, right? Then 1/2 minus 1/3. Again, I'm taking all of the values in blue and subtracting that 1/3 to shift the graph to the left. That's a positive pi over 6. And then 2/3 minus 1/3 will be pi over 3, right? Okay. This is asking us to graph this over 2 periods. I'm just going to do one, and then we'll see where the second period was drawn. Okay, so we've got our x values. For the y values, for cosine, normally, for cosine, we start at the max, go to the center, min, center, max. This is the pattern that cosine normally follows. But because we're reflecting over the x-axis, all of the max and min values are going to switch, right? Because we're reflecting over the x-axis. Okay. So the center is going to stay at 0. So that'll be here and here. Our minimums are going to be at -2. We've got an amplitude change. And our maximums are going to be at +2. Okay. So let's look at where these points are. Negative pi over 3, -2. That's right here. That's our first point. The next one is negative pi over 6, 0. That point is here. Next we have 0, 2. That's here. Then we have pi over 6, 0. And then pi over 3, -2. So that's one period, just this part that I've got highlighted here, going like this. That's the part I found the values for. At this point, you could either continue the graph You could have the whole graph continue like this again, or you could go back the other way. In this particular graph, what they did is they had a little bit go to the right and a little bit go to the left, half of a period to the right and half of a period to the left. But that's the process you use to find the 5 key points. So we talked about horizontal translations. Now we'll talk about vertical translations, which shift up and down. When I have a number that's added, the whole graph shifts up. That would be the case right here. And if I had a number that's subtracted, that's going to shift the whole graph down. Sometimes when you see things written like this, they'll put the number on the after the function. They might put it like this or this. But just note that it's outside of the parentheses. When we have a phase shift, it's inside the parentheses with x. If there's a number outside the parentheses, that shifts up and down. And in this case, it goes, when it's outside the parentheses, it goes in the direction we would assume. So plus means up and minus means down. It's not going in the opposite like it did with the horizontal translations. All right, so let's look at this. This has got a lot of things going on. I'm going to rewrite this over here. Y equals -2 cosine of 3 times x, and then I'm going to put the +3 on the back side. I just took this value and put it over to the right. Okay. So because there's not a value that's going to make a phase shift, we don't have to factor that 3 out. It won't make too much of a difference. But we know that the period of this graph is going to be 2 pi over 3. We know that the amplitude is going to be 2. It's reflected over the x-axis because of the negative sign. And the whole graph is going to be shifted up by 3 units, right? That's what that 3 does. So we're just denoting what each of the parts of the graph are going to do, or of the function. Okay. So we'll make our XY chart here. We don't have a phase shift, so we don't have to worry about moving the x values. So I'm going to start at 0 and go to 2 pi over 3, which is the end of the period, pi over 3, pi over 6, and pi over 2. Kind of know those from the last example that we did. For the y values, cosine normally follows the pattern of max, center, min, center, max, right? The negative sign is going to have all of the maxes change to mins and all the mins change to maxes. Now, normally those values would be 0 for the center. Minimum is going to be at -2, remember, because of the amplitude. Maximum at 2, minimum at -2. Okay, notice I've written them off to the side. So what I've done is I've taken the reflection into account here. This is where we look at the reflection. And then this is where we looked at the amplitude. Now the last thing that we have to do is think about the shift, the up. So all of these values in blue have to be shifted up by 3. So I'm going to add 3 to all of them. So -2 plus 3 will be 1. 0 plus 3, that's going to be 3. This will be 5, 3, and 1. So here are my values. 0, 1 is here. The origin, this graph is kind of weird the way it's written. The origin is down here. And then the next point we had was pi over 6, 3, which is here. This line that's dashed, we call that the midline. In all the graphs we've done before, the midline was at the x-axis, which was at y equals 0. But because the whole thing is shifted up because of that +3, the midline gets shifted up as well. So the amplitude, the max and the min values are going to be up from the midline and down from the midline. Our next point was pi over 3, 5, pi over 2, 3, and then 2 pi over 3, 1. So we can see that there's one period of the graph, and then we just made a carbon copy on the other side there. Here's our last example. Pretty complicated because it's got all 4 components happening at the same time. So let's take each one of them systematically. The first thing that I'm going to do is rewrite this in a way that's maybe a little easier for us to take each of the components apart. So let's write this as y equals 2 sine of, I'm going to take the 4 out of the parentheses, 4x plus pi over 4. I factored the 4 out. And then I'm going to take that -1 and stick it onto the end. Okay. So we know that the amplitude is 2. We know that the period is going to be 2 pi over 4, which is pi over 2. This is the phase shift. The whole graph is going to go to the left by pi over 4. And this is a vertical translation. The graph is going to go down by 1. Looking at this picture that we have here, we can see that the midline is at -1, right? Because the whole thing got shifted down by 1. All right, let's start by getting our 5 points. The period is pi over 2, right? So we'll start at 0. We'll go down to pi over 2. The middle of that is pi over 4. The middle of this is pi over 8. And then 1/4 plus 1/2. And then divide that by 2. You add the two items together and then divide by 2. And we're going to get 3/8 or 3 pi over 8. All right, this is what the breakdown of the period from 0 to 1/2 would be. But then I have to take into account the phase shift. So anything that is inside the parentheses is going to affect the x coordinates, right? Because it's sitting near the x. So that's going to be the period and the phase shift. And so we look at those values when we're trying to determine what our x values are. Anything that's outside the parentheses is going to be related to the y value. So when we talk about the amplitude or the translation, that's going to affect our y value. So we take those two numbers on the when we're talking about the other side of the t-chart here. So we need to subtract pi over 2. The whole graph is shifting to the left by pi over 4. So we're going to subtract pi over 4 from all of these to get the x values. So negative pi over 4. This is going to be negative pi over 8. 0. I think that's going to be (1/8) pi over 8. Yeah. And then this will be pi over 4. Okay. For the y values, we'll think about what the pattern is that sine usually follows. Usually sine starts at the center, goes up to the max, center, min, center. We don't have any reflections, so we don't need to change any of those. We are going to take the amplitude into account. All of our center points are going to be normally at 0. The max would be at 2, and the min would be at -2. But we're going to subtract 1 from all of those because the whole graph is shifted down. So I'm going to be at -1, 1, -1, -3, -1. I'm taking all the values in blue and I'm subtracting 1 to get my final y values. And then let's look at our graph. Our first point was -π/4, -1, which is here. Then we had -π/8, 1, which is here. 0, -1, π/8, -3, and π/4, -1. So this gives us one period of the graph. They added another one to the right and another one to the left to get 2 complete periods. All right, I know that this is a lot of moving parts. The graphs that I will ask you about normally won't have all 4 components. They'll typically have 2 components at one time, but you will be able to use Desmos to get these graphs. I'm going to be asking you to give me some of the underlying algebra to support the answers that you're getting, the pictures you're getting in Desmos. Thanks for watching, and I will see you in class.